Welcome to another week of our pre-lab videos here for the Chem 1211 lab in North Georgia. This week we're going to be taking a look at a series of copper reactions and really just looking at different ways we can kind of react and transform copper and really eventually go in a cycle and just kind of get the copper metal back that we actually start with. So this is just kind of a very, very quick kind of summary of all the different reactions we're going to be taking a look at, which looks like a lot and really it can be kind of time consuming. But hopefully what I'm going to outline here kind of in this video is just for each of these different steps, taking kind of a quick review of kind of what type of reaction we're really looking at, but also then from an experimental standpoint, what are we really looking for to know when this reaction step is completed, and what are the things we should be kind of aware of as we're doing that particular reaction step. Because really this week's lab is much more experimentally focused, and there's not as many kind of calculations or other pieces that we're going to spend a lot of time focusing on. But I do want to kind of at least highlight each of the different reaction types, and again, what we're focusing on for each of them from the experimental point of view. So starting with the first step of the reaction, our initial kind of step is actually going to be a redox reaction. For those of you that haven't talked about oxidation or reduction reactions, or which oxidation and reduction combined is where this redox term comes from. But if you haven't talked about redox reactions yet, probably see them shortly in the next week or so for lecture. And what happens in a redox reaction is you change what's called the oxidation state of some of the elements in that particular reaction. So in our case, like we have copper here that's just neutral copper. And over here, this copper ends up actually having this 2+ charge on the product side. And so the charge of copper ends up kind of changing throughout the experiment. And that basically means that electrons are being kind of taken off of elements or added to elements as well. And that's what really kind of the oxidation and reduction part really focuses on. Like oxidation is when something loses electrons. It's like in this case, the copper lost electrons in this process, so it's oxidized. Nitrogen actually ends up being the element that gains them in this case. And that's kind of the redox reaction that's occurring. We have an oxidation and a reduction, something losing electrons, something gaining them through the reduction. Now, in terms of the experiment side of this, and kind of what we expect to see, starting out with a copper metal, we're just going to have actually like a really thin strip of copper wire. And really one of the best ways to dissolve metals, because metals don't normally dissolve in just water. And so if you want to dissolve a metal for a particular reaction, you usually have to oxidize it first. And so that's basically what we're going to do. We're going to use nitric acid to oxidize our copper wire, which will dissolve it as that reaction takes place. But we do want to be kind of cautious here because there's a couple things to pay attention to. First, we are going to be using concentrated nitric acid for this step. So do be careful handling it. We're not using very much. But if you do get nitric acid on your bare skin, you will feel it. It will burn a little bit. It'll probably actually even turn your skin a little yellow if you get some on you. So you will know if it happens. It's not the end of the world. Just if you do feel like it, you probably feel your skin slightly tingly or burning, just wash it off quickly with water. Tell your professor, what happened, take a look at it, but usually it's not going to be that big of a deal. We don't have enough of a volume here to usually be a problem. The other part of this first step, it has to be done in the hood. And the reason I say it has to be done in the hood is as you do this reaction, you're going to notice there's a brown gas given off. That's this nitrogen dioxide gas over here. This is a slightly toxic gas, and so we have to do this reaction in the hood so that we're not basically exposed to or at risk of just inhaling these vapors. So until the copper wire is dissolved, we want to basically leave this reaction in the hood, and that's really how we know the reaction for this first step is done. We're just waiting for that copper wire to be entirely dissolved. Now, for color-wise, visually what we're looking for here, when that wire is dissolved, we should see a kind of our solution that's created turn kind of a dark green color. And then as you add a little bit more water, you'll probably see it start to turn more of a bluish hue over time. And here's just kind of some quick visual images there. Like once we have our copper wire entirely dissolved, again, kind of like that dark green color, adding more water might turn a little bit light blue before you start adding the sodium hydroxide for that next step. And so that's kind of everything for our first reaction that we're going to look at in this lab. Our second step, we're going to be doing a precipitation reaction. So kind of similar to the reaction type that we talked about this previous week in lab. And for this one, we're going to be taking our copper that's basically been dissolved. And for this equation here, as far as you've seen these waters, all these waters are really just attached to the copper. They're all attracted to the copper. And so that's what gives it actually kind of the bluish colors when this happens. But what can happen is with this copper dissolved in water, if we add hydroxide ions to it, the hydroxide and the copper can actually combine to make copper hydroxide, which is going to be insoluble in water, and we get a precipitate that forms. And so we have a precipitation reaction that's happening. But a couple things here, we are using sodium hydroxide. This is a strong base, so we want to be fairly careful. Strong bases, like strong acids, can also be potentially dangerous. And this is a fairly high concentration. I think it's 6 molar for the sodium hydroxide. So if you get that on your skin, you will probably also know, although it won't feel quite the same, What will happen with usually with a base is your skin will start to feel a little bit slippery, mainly because what's happening almost like soapy in a sense, and that's because the sodium hydroxide is basically turning your skin into soap. And so if you feel your hands get kind of slippery at this part of the experiment, again, just go to the sink, wash them off good. It shouldn't be that big of a deal. We don't have huge volumes here again. But again, if you want to, we have gloves available. By all means, just wear gloves in the first 2 steps, and you don't really have much to worry about there either. Now, when you're adding the sodium hydroxide for this reaction step, for the precipitation reaction, you do want to do it fairly slowly and with constant stirring. Because what's going to happen is as you add little bits of sodium hydroxide, you're probably going to see this copper hydroxide solid form. It's a really kind of brilliant royal blue color. But what happens is you stir it a little bit and that solid dissolves right away again. And so what you're going to do is you're going to kind of keep slowly adding sodium hydroxide until that blue solid basically stays and doesn't go away anymore with stirring. And you want to do this relatively slowly because that sodium hydroxide, as you add it, since we just used nitric acid in the previous step, like sodium hydroxide and nitric acid can do an acid-base neutralization, which those reactions give off a lot of heat. And so that can heat the solution up a lot, and so you want to be careful because that might turn your solution black instead of blue in color, and it's going to be a little harder to tell when it's done right. And so make sure you're adding that slowly. You should see that blue solid form and eventually persist as you stir it, and that's when you know the step is usually typically done. We can test that then with pH paper as well to confirm that the solution is basic, and that's when we know we pretty much should have the maximum amount of the copper hydroxide we can make. Now, once we get to the end of this step, as you're getting really, really close to being at the end of this step, you'll probably see your solution actually turn a slight greenish color, or kind of like a cloudy greenish blue where the solid's not really dissolving. If you add just a little bit more sodium hydroxide, it'll kind of go more of that royal bluish color with a bunch of solid now that doesn't dissolve anymore. And that's really what you're looking for kind of at the end of this precipitation reaction step. Once this part is done, we're going to be diluting our solution down more, so we're adding just plain water at this point, like deionized water to our reaction, and then what we're going to do is heat it. But this is what we should see before we dilute it even further. So we should see this nice royal blue color, and it's a bunch of solid. You can see how you can't really see through the solution anymore because you basically have solid chunks floating all around it. And so that's what we're looking for at the end of that second step visually. And then for the third step of this reaction, we're going to do something that you might not talk about this specific reaction in lecture, and that's fine, but it's really just a decomposition, where we basically take our copper hydroxide as a solid, and we're just going to heat it up using a Bunsen burner to heat our whole solution really quickly. And what's going to happen is we're going to decompose this copper hydroxide into copper oxide, and it's going to give off water, which may be liquid or maybe in the gas phase because this is going to be heated up pretty hot. Now, setup-wise, this step's going to look pretty similar to what you did for the empirical formula lab. We're going to be using a Bunsen burner, so your lab has a pretty good image already for it, kind of on the setup. I'm not really going to show too much with that again. I think that's not too bad. But the key here, as far as once you get your Bunsen burner going and you're starting to heat your solution, is that it's not a particular amount of time that you're heating your solution for. What you're really doing is you're heating it until you see a color change for all the solid and just the solution color itself. You should see pretty much all the solid that's kind of floating around your solution, instead of being blue, should turn very black instead. So it should all become like a brownish black color. Once you see that, you know you're pretty much done with that step. If you've been heating it for a really long time and you haven't seen a color change, then that's kind of a problem. You should see that color change happen relatively quickly. If you don't see a color change, there's a couple things that could have happened. One, you might just have your flame way too low below the beaker and you're just not heating the beaker enough. That's a possibility. But the other ones are if your flame has been heating the solution and you can see it almost boiling and the solution is still blue, then you can heat it a little bit longer. It shouldn't take much longer if the solution's already boiling to get that color to change from blue to black. But if you see your solution been heated for a really long time and it's still almost kind of like a greenish hue more than blue, probably you need to add just a little bit more sodium hydroxide. And adding just a little bit more sodium hydroxide should precipitate out the last bits of the kind of that blue-green color that's still dissolved, and that'll precipitate it as a solid, which then the heat can help decompose to the copper oxide. And so green color, a little more sodium hydroxide, and then it should all turn black actually pretty quickly if it's been being heated for a while. But that's really what we're looking for in this third step. We're just going to heat this thing up, look for that color change to basically have a black solid, and then we're going to let it cool back down. Now, visually, again, kind of here what we're looking for. This is after the heating's kind of done and we had a chance for all the solid to kind of settle to the bottom. And what should happen is we should see that all of our solid at the bottom should look kind of black in color and the solution itself should be clear. If If your solution here is still blue at this point, you should probably add a little more sodium hydroxide and heat it again, just so we can try to get all the copper basically out of that solution. Because for this lab, anytime the solution is blue, that's because there's copper still dissolved in it. And we can't really put copper down the sink, so that's something we always want. We actually want to get all of our copper back out of solution as we go through everything in this lab anyway. All right, now once we have that copper oxide form, that kind of black solid, we're gonna have to do a gravity filtration so that we can before we can do the next reaction. And so the gravity filtration, we did that back in the separation lab a couple weeks ago. And for the sake of speed, something that can help is you can do what's called decanting a lot of that liquid. And what that entails, if you're going to decant a solution or a liquid, you basically, when your solution's settled, so if I back up to kind of our image here for a second, you notice all the solids at the bottom. What you can do is if you just take this and very slowly try to pour off like what's on top, you can actually pour off just the liquid and not really have any of the solid come with it. And that's really what decanting is. So when you first start to filter, try to pour just the liquid, because if there's no solid on your filter paper yet, this stuff will filter really, really fast if it's just water. But once all the solid starts getting on your filter paper, it's going to filter really slow, and sometimes this can really slow down your experiment. So whatever you do, do not mix this thing up so where your solid's all over in the solution before you filter it. That will just slow down the time it's going to take to kind of do this filtration step, because we're not doing the vacuum filtration this week. Now, once you do filter it, you should have all of that black kind of brown copper oxide product sitting on your filter paper, hopefully looking kind of something like this. And that's when you're pretty much ready to go on to the next step. And again, your filtrate at the bottom, that solution at this point should be clear. As long as it's clear, you can go ahead and just pour that down the sink. You don't have to keep that for anything at this point. What we want is all this kind of black and brown sludge or solid that should be stuck to your filter paper. All right, next step, the actual reaction part here for the fourth real reaction that we're going to do. We're going to redissolve the copper oxide by adding another acid, although this time it's not going to be nitric, it's actually going to be sulfuric acid that we're adding. That is important to make sure we use the right acid at the right time. And what you're going to do is you're going to take 10 milliliters of sulfuric acid, add it to your filter paper, and you should see some of that copper oxide start to dissolve. It's not all going to dissolve right away, that's fine. But what you're going to do, instead of getting more acid, you're just going to keep reusing that same 10 milliliters and just pass it over the filter paper kind of over and over, kind of in repeated cycles. So you'll probably need like 2 beakers to collect stuff as it's coming through the filter paper, so that once it's all passed through, you stick the other one beaker under it and take the beaker that has your solution in it, pour it back over your funnel, and just kind of keep cycling like that until you get all the contents off of your filter paper. And what you should see is a nice blue solution that's coming through the filter paper because that's redissolving your copper, and again, the copper dissolved in the water should have that blue color to it typically. And this step should be done when you dissolve just about, or hopefully all, of that black solid off of your filter paper. Like I said, it might take a while, it might even take more than 3 or 4 cycles that I mentioned here, depending on kind of how stuck to the filter paper it is. But just kind of a quick visual, you should see a nice blue solution. Here you see there's still some kind of blacker solid still up in the filter paper, so this filtration's not really done yet for trying to get all of that stuff dissolved. Almost all of this should dissolve in the sulfuric acid if you kind of just cycle it through a few times. Now, once you do get everything dissolved, we have one final step, reaction step that we're going to go through for the reaction, for kind of our whole cycle, and that's to get our copper solid back. And so how that's going to work is we're going to take our copper that's in solution here, our blue solution, and we're just going to add solid zinc to it. And when we add that solid zinc, what's going to happen is we're going to see that basically we're going to get another redox reaction, where this time the zinc goes from being neutral to charged, so the zinc's getting oxidized by losing electrons. Our copper in this case is going to go from really copper 2+ to copper metal, so it's getting reduced, and we get this back as kind of a brown-red solid. And so we should see this nice reddish-brown solid at the end. That should be what we want to collect as our final product. And for this step, a couple things here, because this is a step that can really slow things down. You want to add the zinc slowly until the solution itself ends up just being clear. And so once the solution is clear, that means all the copper should be out of it, and you shouldn't need to add any more zinc at that point. But you do want to be careful. You don't want to add a huge excess of zinc because then you have to actually try and redissolve that zinc so it doesn't end up mixed with your final product. And to redissolve the zinc, you have to add sulfuric acid, and that step actually takes a little while to do. So it can take a really long time to dissolve excess zinc with sulfuric acid. But you should be able to tell that the excess zinc is gone is if you add a little bit of sulfuric acid and it doesn't bubble anymore, and if you don't see any kind of solid silver chunks floating anywhere in the solution. And so those are some things to kind of look for. So we want the solution to be clear, and we don't really want to see a bunch of silver chunks that are kind of bubbling around them from the sulfuric acid that's in the solution. That's what we want to kind of look for this step to kind of know that it's actually done. And so visually here, you have kind of a couple comparison images, like the image here on the left. If you're looking at the solution, and I do encourage, like when you're doing this part, to try and tell, is the solution clear or is it not? Hold it up against something white. It'll just be the easiest way to see if that solution is really colored or not. Here you can very clearly see that blue color. If you put the solution though on top of this black countertop, you probably can't tell that it has a little blue color to it. So do use kind of like a white background to help differentiate. Over here, we don't really see that same bluish tint. If anything, it almost looks kind of green or blackish. And that's mainly just because it's still a little bit of this actual solid kind of dispersed through the solution. So this one looks like it's got all the copper precipitated out. This one looks like we still need to add some more zinc to get the last of the copper. So that's kind of visually what we'll look for. Once we get to this point that we see here, you have one more filtration to do. And all you're going to do is basically collect that solid that you see here. It should be kind of a reddish brown color. Collect that on a piece of filter paper, and you're just going to let that dry overnight and get a final product mass really the day after you do the experiment. So you'll basically do this whole lab all the way to the end. You'll have your copper on a piece of filter paper, and you're actually going to let it dry overnight so that you can get a semi-accurate mass. Unfortunately, it's not something we can just go stick in the oven and heat to try and get dry. It's a little. This one's been exposed to more water, and the copper doesn't really dry out as easily. And the heat's also not very good for it, unfortunately. It can oxidize the copper back to copper oxide if it's heated for too long. All right, so last couple notes here. Like I said, once you have your final product, you're going to come back and just mass it the next day. Please try to come back and mass it in the day or two after you do your experiment. If the product's been left like for 2 or more days just sitting in the lab and you haven't come back and massed it, it may get thrown out because we have a lot of sections and we only have so much bench top to kind of set things out and let them dry for a day. So if you don't come back and get your mass within 2 days, there's a good chance that we will throw your product away, whether you've come back and massed it or not. When you do come to mass your product, please go ahead and just throw it away, and it can just go straight in the trash. There's no special disposal for the copper product. You can just throw it in the garbage. And then the last kind of final thing is just to make sure to remind people as they're doing the lab, just make sure you use the correct acid for each step. You'll be very sad if you use the wrong one at the wrong time. Like at the start, if you use sulfuric, your product will never dissolve. It will pretty much just never dissolve. And so you have to use nitric for the first step. And for this, like towards the very end, and you're redissolving your copper oxide, you have to use sulfuric acid. Because if you use nitric, that copper is never actually going to precipitate out when you add the zinc, and you're just never going to get a solid again. Like if you add nitric in that second to last step instead of sulfuric, you're basically going all the way back to step 1. And you have to redo those other steps to get back to the end. And so it's just a huge time sink at that point. So make sure you use the right acids at the right point throughout this experiment. And then the last thing, like I've tried to highlight, I think hopefully most of the way through these different reaction series here, just pay attention to the color changes, and that's the easiest way to usually identify when each reaction step is done. And that's kind of the main thing we're going to usually look for all of these. And like I said, hopefully this is kind of pretty enjoyable lab. It can be a little bit on the long side time-wise, but I think this is one of the neater labs we do this semester in terms of just being able to do reactions, see a bunch of different color changes. It's just a lot more, I think, visually kind of interesting and to kind of follow along with. So hopefully everyone enjoys it.